Tick tock, the sun is dying and it will heat up and boil every ocean on the planet. We need to escape before that happens if we want the human race to go on. We need solutions. There are 5 ways to save ourselves. One of them moves the earth, one of them moves the sun, and the last one is an idea only a madman could think of. Option 1 is the stupidest one, so obviously we'll start there. You put something in front of the sun. That's the whole idea. Sunglasses for the planet. 1,000,000 miles up there, there's a spot where Earth's gravity and the sun's gravity cancel out. Park anything there and it just sits. Doesn't drift, doesn't fall in. Free parking space. Imagine that. Earth could never. So you fill it with glass discs, trillions of them, 2 feet wide, 1 gram each. 1 gram, that's like a butterfly. They don't block light, they bend it. 2% of the sunlight aimed at us just slides past instead. How cool is that? It's not that cool, but yeah, whatever. 2% sounds pathetic. It's not pathetic. 2% is the entire greenhouse effect of doubling the CO2 in our atmosphere. One shade and the climate crisis is just gone, deleted, which would be amazing if that were our only problem. 20 million tons of glass. And rockets can't lift all that. You need cannons. We need to invent electromagnetic cannons. Each one throws those discs at a speed of 12 kilometers per second. Do you even know how much force that is? Of course you don't. That's 4,000 Gs of force. And the free parking? Not actually that stable. Stop steering for 3 weeks and the whole cloud wanders off. You need to coordinate it, which creates a lot of complications. It wears out in 50 years anyway. Then you have to build it again. So option 1 could work, it just has a big requirement. Humanity cannot drop the ball. No wars, no collapses, no budget cuts. Everyone needs to contribute. Do you think that's realistic? Do you think that Indians will do their part? Fine, forget the shade. We move the Earth. We move the whole goddamn planet to right about where Mars is now. Now that it's further from the sun, the problem's gone, right? Well, the energy that it takes is so far out of reach, it's amazing. We could turn this entire planet into a power station and not get close. So we don't make the energy, we take Jupiter's. You grab an ice ball from out past Neptune, 100 miles across. Doesn't matter which one, Neptune won't mind. Nobody's using them. Take one, it's free real estate. Put it on a long stretched orbit so that it swings all the way into Earth and then all the way back to Jupiter. And then it just keeps orbiting like that. Forever. Every time it cuts in front of us, its gravity drags Earth forward a little. We speed up, our orbit widens, and the ice ball loses exactly what it gave us. Then it reaches Jupiter, swings around behind it, and takes that speed straight back off of Jupiter. And Jupiter's orbit shrinks by a teeny tiny bit. So Jupiter is paying for this. Jupiter did not agree to pay for this. You see, Jupiter has so much orbital energy that we could keep robbing it until the sun dies and it would barely even notice. So it's fine. So it's 1 flyby every 6,000 years. That's it. That holds the Earth at exactly today's temperature for the next 5 billion years. Another little detail, that's about 1,000,000 very close flybys. And every single one has to not hit, come in slightly too close, and the plan to save Earth becomes the largest impact in Earth's history. Also, the moon probably comes off. The people who wrote this paper mentioned that in passing, like a footnote. Or, and hear me out, we stop living on planets. Everybody's first answer is Mars. Mars is not a backup. Take every molecule of CO2 left on that planet, ice caps, soil, minerals, the whole inventory. Release all of it at once. You get under 7% of Earth's air pressure. There's nothing there to work with. Mars is not the answer. So build one yourself. A cylinder, 20 miles long, spinning once every 2 minutes. That spin presses you into the inside wall. Your body cannot tell it apart from gravity. It's not a trick. As far as you're concerned, it is gravity. Ground on the inside, sky down the middle, and the weather is whatever you decide it is. You could play Samba de Brazil every single day, for all I care. Most of the weight isn't even the building. It's radiation shielding. 15 tons of rock for every square meter of floor you want. Now you might be saying, but where will we get all that rock from? Isn't that a lot of rock? We don't have enough rock. That is why You don't build these out of Earth, you silly. You build them out of asteroids. And there's enough rubble floating around the asteroid belt for roughly 1,000 times the surface area of this planet. 1,000 Earths out of gravel. Then you check what's powering it. Mirrors pointed at the sun. Heat, crops, electricity. Every bit of it is powered by sunlight. When the sun swells up, those mirrors catch a furnace. When it burns out, they catch nothing. 1,000 little Earths. All of them dark. Alright, take the sun with us. Sunlight has pressure, actual physical push. The sun is pushing on everything around it in every direction at once, which is exactly why nothing happens. So you break the tie. You hang a mirror the size of a planet off one side of the sun, not attached to anything. It just floats there, held up by the light hitting it. Now the sun is pushing itself one direction and it never switches off. 1,000,000 years of that and you're doing walking pace. That's not a mistake. 1,000,000 years for walking pace speed. But you see, it doesn't stop. The speed adds up. 1,000,000,000 years in, and you've dragged the entire solar system 34,000 light years. A third way across the galaxy. Every planet still in orbit, nobody on board feeling a thing. But also there's a faster design that runs on the sun's own wind. You park an engine next to the sun, scoop up the particles blowing off of it, and fuse them. Then you fire a jet of hydrogen straight into the sun. That mass lands on the star and it just pushes it. That's the plan. Problem is that firing something that hard at the sun kicks your engine backwards, away from the sun. So there's a second jet, oxygen, fired the opposite way, fast enough to hold the engine in place against its own exhaust. One jet moves the star, the other one exists purely so the first jet doesn't throw your engine into deep space. It gets you 200 kilometers a second in 5 million years instead of 5 billion. But moving a star doesn't slow it down. You've changed the address, but the sun is dying on exactly the same schedule as it was before. Which brings us to the madman. Every plan so far treats the sun as a fixed object, but it isn't. A star's entire life, similarly to a female, comes down to one number: how much mass it's carrying. More mass, more crush on the core, hotter burn, faster death. The biggest stars are gone in a few million years. The smallest ones burn for 10 trillion. So shave some mass of the sun. You build collectors around it. Skim off a slice of its own light and beam that light straight back down at the surface. Heat one patch hard enough and it lifts away. Then magnetic rings squeeze the rest out through the poles. The whole operation costs under 1% of what the sun already puts out, which means the sun funds its own disassembly. Now, search this and you'll be told star lifting keeps the sun alive for trillions of years. Somebody finally ran it through full stellar evolution models, and the real answer for our sun is 2 to 3 billion extra years. Not trillions, just billions. It's still a lot. But that's not the good part, you see. The same model has been ran on smaller stars. On a small star, stripping mass doesn't buy billions, it buys hundreds of billions. So that's the actual plan. You don't save this star. You use the time it buys to reach a smaller one. And then you strip that one. And it burns for hundreds of billions of years. None of this is science fiction. Every one of them is published work with the math attached, written by people who were completely serious. And before you go, I'ma be real with you, it would be very helpful if you could spare some time to tell me what do you think about the video. I just started this YouTube thing, so I know I'm probably doing a lot of things wrong, but I would like to hear your opinion. How do you think I could improve these videos even more? And yeah, sincerely, thank you for watching this.